Okay, so picking up where we left off from our first video, I've introduced the topic to you, and I think we're ready to start some examples of collecting like terms. So, going through one of these rules that are a part of algebra, the language of math. So, let's start with 3x plus 2x. Okay, so imagine it because they're both x terms, so each of those terms, there are two terms, each of them has an x in it. Okay, that means that they are like terms and we can add their coefficients or subtract their coefficients together. Okay, so I want to stress that there are two terms here separated by a plus sign. So 3x plus 2x is like saying 3 cats plus 2 cats. It is simply 5 cats or 5x. Okay, that one's pretty straightforward. Next, once again, check if they are like terms. They are. And again, there are two terms. They each have an x variable. And 3x minus 2x is 1x. Now, in math and in algebra, one of the rules is, and it's not really a hard rule to follow, but when you have 1x written out, it's understood that that means that it's just x. Okay, so you don't show the 1. You don't show it. If you get an answer or you have something that is 1x, you typically don't show the 1 and you just write it as x. Okay, so keep that in mind throughout this unit because that's going to come up probably in every lesson. Okay, this next one is a little bit more challenging. It says 2x squared minus negative 5x squared. Okay, now they are both like terms. Why? Because they both have x squares. Both terms have x squares, so they are both like terms, so we can add and subtract these together. But what we see is a minus, a negative. So we see a minus, a negative side by side there. And knowing our integers, when you have a minus and a negative side by side, you actually add. Okay, so it turns to adding. So we have 2x squared plus 5x squared. Okay, because of the minus a negative, it became plus. And our final answer then, because they're like terms, we just add their coefficients, 2 and 5, and we get 7x squared. Okay, so we're just simplifying. Again, the instructions are to simplify. We're not solving. This isn't called solving anything. We're not solving. We are simplifying. We are simply taking an expression and making it more efficient, right? So instead of saying 2x squared minus negative 5x squared, we can just say 7x squared. Okay, so we're just taking these expressions and making them more efficient. And in doing so, we're practicing these algebra rules. Okay, let's keep going to something a little bit more challenging. Okay, again, it says just simplify. Simplify the following algebraic expression. Okay, so if you see here, we have like terms scattered throughout. We have two terms that are x squared. Those are like terms. We have two terms that are x's. And then we have two terms that are just numbers. Now that looks a little sloppy, so I'm just going to delete what I have there. But you get the idea. There are two x squares, there are two terms that are x's, and there are two terms that are just numbers. Okay, so each of these pairs are like terms. And we can collect them and simplify. Okay, so we can take this expression and simplify it. So 3x squared minus x squared. Remember, what number is in front of x? That if you don't see a number there, what number is really in front? Just like I said above, it's a 1. Okay, so you have 3x squared minus 1x squared is 2x squareds. Okay, we have 2 left over of the x squares if we do 3 minus 1. Next, and I'm just going to erase what I have here just to kind of make it less busy so I can use it to explain. Next, I have, and you always take the sign that's in front, you have negative 5x plus 4x. Okay, so that minus sign right there, minus and a negative mean the same thing. And so when you're simplifying and you're collecting like terms, you always take the sign that's in front of your coefficient. So in this case, I'm calculating negative 5x plus 4x, or minus 5x plus 4x. They mean the same thing. So if you grabbed your calculator and you did negative 5 plus 4, you should get negative 1. So we have minus or negative, same thing. So minus 1x. So far we have 2x squared minus 1x. And now in your calculator again, just do a positive 4 minus 1. Okay, a positive 4 minus 1, which is positive 3. So our final answer there, if I were to write this properly, is 2x squared, and instead of minus 1x, simply put just minus x, and then plus 3. Okay, that's our final answer. And you probably want to put a box around that just because you want it to stand out from your solution. You want it to stand out. Okay, so hopefully you understand there that I collected like terms. I identified that the x squares are like terms, the x's are like terms, and the numbers are like terms. And then I simply used my calculator to add and subtract their coefficients. Okay, let's try the next set of examples. 2x plus 3x minus 4x. Okay, so again, we're simplifying. We're collecting like terms. As you can see, these are all x terms. They are all the same. Simply pull out your calculator and do, it's like saying 2 cats plus 3 cats minus 4 cats. How many cats do you have left? Well, in your calculator, just do 2 plus 3 minus 4. You get 1x. But remember, write it as simply x. Okay, when you have a 1 in front. Next one. Okay, here this is getting a little bit more complicated because the like terms are not beside each other. Take a look here. I have 2y here and I have positive 8y there. So what I suggest you do is reshuffle this around. You can take this expression and just shuffle around your terms. So instead of putting the plus 8y there, just move it in front of the negative 6x and reshuffle this expression. So you get 2y plus, remember, always bring the sign that's in front. Okay, always bring it with it. So plus, a lot of students would have put minus here, but you bring the positive sign with the 8y. Always, always. Then, let's just erase and clean this up a little bit. Bring the whole minus 6x here, just so that it's beside the minus 2x, which is there. Okay, so look at what I did here. I got the y's and I brought them together right here. Then I got my x terms and I brought those together. Just remember to bring the sign that's in front. Okay, so bring sign. Always, the sign that's in front of the coefficient comes with it. Now that I've shuffled it around, now I can collect like terms. 2y plus 8y is 10y. And then if you need to do negative 6 minus 2, if you can't do that in your head, it's okay. Just pull out your calculator and do negative 6 minus 2. You get negative or minus 8, same thing, x. So notice that I got negative 8, and I just simply wrote down minus 8x. This is the part where students get most confused with. The minus and the negative are the same thing, okay? So please just write down your minus 8x. I'll get a lot of students often do this. Often a lot of students will do this, and they'll put it around brackets. Putting it around brackets totally changes this. This is not correct. Okay, it's not 10y times. When you put brackets here, you're insinuating that there's a times symbol in between. There's no multiplication in between the terms here. Okay, there's no multiplication there. So please just simply write down the sign and then the variable that goes with it and the coefficient. So minus 8x. There's your simplified expression. Can you go any further than this? No. No, because we have a y term and we have an x term. Those are not like terms. So, box your answer. You are done. You have gone as far as you can because you cannot collect any more like terms. Okay, next. 5x squared minus 3x squared. Okay, 5x squared minus 3x squared. Well, these are like terms. They have the same variable and the same exponent. But then this is not a like term. So that's kind of out on its own. So this one's easy. 5x squared minus 3x squared is 2x squared. And then just rewrite the plus 6x. Remember, the sign that's in front of the 6x is a plus. Just bring it down. And you're done. You cannot go any further than this because these are not like terms anymore. These are not like terms. You have to have the same variable and the same exponent. And these only have the same variable. They